Okay, question 13. We have a golf ball at rest on a horizontal 1.3 meter hole. A golfer hits the ball so that it moves horizontally with an initial velocity of 1.8 meters per second, and the ball experiences a constant deceleration of 1.2 meters per second as it travels to the hole. It says calculate the velocity of the ball as it reaches the edge of the hole. So we know that initially it's moving at 1.8 meters per second. So there is a speed in this direction of 1.8 meters per second. We know that it reaches this position here with some speed v, and along the way it is decelerating with not but a deceleration of minus 1.2 meters per second squared, and that's significant, the negative sign here. Okay, so now we're going to put all those values on the side here. U is 1.8 meters per second, that's initial speed. The displacement is 1.3 meters. The acceleration is minus 1.2 meters per second squared. And we know that it's negative because it is decelerating. We don't know the final velocity, nor do we know the time it takes for the ball to get from here to here. So what we're looking for is final velocity without the time. So the formula is v squared equals u squared plus 2as, 1.8 squared plus 2 times by minus 1.2 times by 1.3, and root all that to find v, and we find a speed which is less than what we started with, which makes sense because it's decelerating, and it's 0.35 meters per second. The next question is the golf ball lands in the sandpit. So there's a sandpit, it's part of the sandpit. The golfer hits the ball and gives it an initial velocity u. So it has an initial velocity u in this direction. So I've kind of shown it slightly bigger here, u in this direction. An angle of 35 degrees to the horizontal. Okay, there's the horizontal and that's 35 degrees. The horizontal component of u is 8.8 meters per second. So we know that if this is u, then the horizontal component is u cos 35 degrees. And we know the vertical component is u sine 35 degrees. Okay, so it says show that the vertical component of the velocity is equal to 6. And there's my mistake, I've spotted it. So I'm going to start again on this question here. So there we go. Let's start again and do it step by step. Okay, so what we've got is we want to show that the vertical component, this u sine 35, is equal to 6 meters per second. And they tell you that the horizontal component of u, this here, is 8.8 meters per second. So u cos 35 is equal to 8.8 meters per second. So what you could do is you can write down the following. 8.8 is equal to the horizontal component, which is u cos 35 degrees. And then we can write an expression that we want to find. So what we can do here is we can find u, okay, which is 8.8 divided by cos 35 degrees. But we also know that we want to now work out u sine 35 degrees because that's the vertical component that we are looking for. And it says show that the vertical component is 6 meters per second. So now we have to show that this here is 6 meters per second. So that we know u is now 8.8 divided by cos 35, and we multiply that by sine 35 because now we've substituted for u, which is 8.8 over cos 35, multiplied by that sine 35, and we should get an answer of around about 6.16 meters per second. Okay, And that's how we do this question. Slightly tricky, and the key is draw this. That will help. Okay, so we know that u cos 35 is the horizontal component and u sine 35 is the vertical component, and that is in the question that says that's 8.8 earlier on in the question here, meters per second. And using that now we can find u, and then we can plug that into here and then find what the vertical component is. It's a little bit much for 1 mark, but nevertheless, that's something that you'll have to do. Question C, we've got the ball's been hit and it arrives at X traveling horizontally. So as it arrives at X, it is moving with a component in of velocity in the horizontal direction. So that means that there is no vertical component when it reaches X, and that's the key giveaway here. So it reaches X traveling horizontally. So there's no vertical component. So it says calculate the time of the ball traveling to X. So what I'm going to do is I'm going to look in the vertical direction. So I'm going to write down suvat. So I don't know what that vertical distance is here. So I'm just going to put a question mark. So that's the vertical distance. I'm not sure what that is, a vertical displacement. U, the initial speed in the vertical direction, we've already worked that out from the previous question, which is 6.16 meters per second. So we know that component in the vertical direction is 6.16 meters per second. Okay, and then we know that the final velocity when it reaches X is all horizontal, so there is no horizontal component, as a vertical component, sorry. So there is no velocity in the vertical direction. Acceleration is equal to minus 9.81, which we know it's in the vertical direction, acceleration due to gravity, and the time is a unknown as well, and that's what we want to work out. Okay, so we don't have S, so I would go with V equals U plus AT, and we can see that we have V, we have U, we have A. So V minus U over A, 0 minus 6.16 divided by minus 9.81, and that gives us the time of 0.63 seconds, and that's the time it takes. So what I've done here is use the vertical components to get to this time here. Okay, now part D says calculate the vertical distance x above the initial position of the ball. So remember we said that's a question mark, we don't know that. That's what we want to find now. So we know that the initial vertical component is 6.16. We know that the final vertical component is 0 meters per second because it's moving horizontally at the point of X. Acceleration is minus 9.81. Time we've just worked out is 0.63 seconds. We don't really need that to do this. So I've chosen the v squared equals u squared plus 2as formula, rearrange for s. V is 0, so 0 squared minus 6.16 squared divided by 2 times the acceleration, and we get a vertical displacement of 1.9 meters. You could get to the same answer using s equals a ut plus a half at squared as well, but I think this is a little easier. The next question, it says the golfer returns the ball to its original position, so back where he started from, in the sandpit, and he wants the ball to land at X, and this time with a smaller horizontal velocity. So in this particular direction, that velocity that it lands with, it's smaller. So sketch on the figure a possible trajectory of the ball. So what we want to do is we want to land the ball at X more vertically. So if it lands more vertically at X, then it's not really moving in the horizontal direction as quickly as before. So the more vertical it lands, and the only way that is to chip it as high as possible so it lands vertically downwards, and that would mean that it has the lowest possible horizontal velocity. So this is a possible trajectory that you could have. Now, explain your reason for selecting this trajectory. So because the ball is taking this trajectory, it's going to be in the air for a significantly longer period of time, as if it was, let's say, a trajectory like that. So time is longer. So the ball is in the air for a longer period of time. Now we know this horizontal distance remains the same. So it has to reach x, which is the same as before. Horizontally, we know that there's no acceleration. So S equals ut. So this horizontal displacement is equal to the horizontal velocity times by time. And since we know that the horizontal distance, this distance is the same as before, because the ball is in flight for longer, that would mean that there is a lower horizontal velocity, because if this is fixed, the displacement, horizontal displacement is fixed, then the horizontal component of velocity is inversely proportional to time. So the longer the flight time, the smaller the horizontal component of velocity.